Okay, two more checkpoints we'll go over in this section, and these both have to do with simplifying algebraic expressions. Hopefully you studied the properties before tackling these two checkpoints. We have commutative properties, addition, multiplication. We have associative properties. We have the distributive properties. All those properties are important, and they're used in simplifying expressions. The book spends a lot of time looking at properties, and the important thing about properties is that they will always work. When you're trying to simplify an expression, if you apply a property, you will get another expression that's equivalent to the one you started with. If you apply some other little rule that you may have memorized here or there, if it's not a property, it might work in some cases, but there might be other cases where it does not work. The properties will always work. So it's important that you learn the properties and use those and not rely on other little tricks you may have learned unless you can prove them to always work, which is what has been done with the properties. This is the first expression we want to simplify. And the first thing we're told to do with the order of operations is to look inside the parentheses. So if we look here, and then we'll try to work inside there and here, try to simplify further if you can. These are not like terms. If they're both x, we can work with it, but one is x squared, the other is x. Can't simplify that. We have the same situation over here, so we can't really do anything inside the parentheses. But we do have a 7 outside, a 2 outside. We can apply the distributive property and rewrite these, and then maybe we can do something to simplify after that. So let's try that. 7, so we multiply 7 by this term and then by that term. 7 times 4x squared, you get 7 times 4 is 28. And then we have x squared. And then we'll have plus, and we're going to multiply 7 times 3x. 7 times 3 is 21. We end up with 21x. Bring this plus down, and we use the distributive property to multiply this out. We'll get 10x squared plus 2x. Okay, at this point you might be able to simplify it and see that, oh, this is just, I put these two together, I have 38x squared, put these two together, I have 21x. But you might want to take another step and reorder them. I'm going to use a commutative property now to rewrite this as 28x squared. And I'll change the order, I'll put the 10x squared over here. It's an addition, commutative property of addition. I'm going to move the 21x over here and put it next to the 2x. Again, using the commutative property of addition. Okay, now if we group these two together, we can simplify this. And when you're combining terms, you're actually using the distributive property. And so I will use the distributive property to put these two terms together. We have 20x squared, 10x squared. They have x squared in common, so I'm going to take that out. What I have here is 28. I'll have plus 10, and I've taken the x squared part out. If you use the distributive property, we can multiply this back out and get those two terms again. We can do the same thing over here. 21 plus 2 in parentheses times x. If you multiply that back out using the distributive property, you'll get those two terms. Okay, now we have 28 plus 10 is 38. X squared, and 21 plus 2 is 23. We have plus 23x. So that would be simplified as far as you could go. These terms are not like terms, and so that's as simplified as we can make it. Okay, the next checkpoint, this one uses some different parentheses. We have regular parentheses, the curved ones, and then we also have the square ones. These are just so you can distinguish them from the curved ones, but again, they're just parentheses, and we treat them like parentheses, the same thing. We should try to start inside and simplify if we can. So let's look at the first set of parentheses, x minus 2. We can't simplify that. However, we can probably remove those by distributing this minus. So let's copy this part down again, and now let's try to distribute that using one of our properties of negatives. If we take the opposite here, we're going to have minus x, and then we have minus negative 2. So don't put minus 2. This is a common mistake this will actually be minus negative 2, which would be plus 2 here. And so I've removed the inner parentheses. Now we should look at these parentheses, or brackets, and see if we can simplify. We have a 7 and a 2. We could put those two together. I'll rewrite this part again. Putting the 7 and 2 together, we get 9. So inside there, we'd have 9 minus x, simplifying this expression. All right, now we could, we have a 4 outside that's multiplied by what's inside here. We can use the distributive property to multiply that out. 4 times 9 is 36. 4 times the opposite x will get minus 4x. Here we can put these two numbers together as 42 minus 4x. These are not like terms. We can't take 42 and subtract 4. There's totally separate terms. And so this is as far as we can go. And that expression simplifies to 42 minus 4x.